All right, we're going to do a quick run through of quiz number 1. So, the first question, it said x, y minus 2, z to the minus 3 over x squared, y to the third, z to the minus 4, in parentheses, all to the negative third power. Now, you could distribute this negative 3 to begin with, but generally I think it's good to work inside the parentheses first. So, I'll put a little invisible 1 here on that x. So when we're dividing exponents, it's the same as subtraction. So we would get x to the 1 minus 2 would be x to the minus 1. Then y to the negative 2 minus 3 is y to the negative 5. Z to the negative 3 minus negative 4 would be the same as negative 3 plus 4 is 1. Then we can distribute. Remember, addition, multiplication, exponents. Each one can distribute over the one that's one below it. So this distributes and becomes a multiplication. And that's just the way exponent rules work. So this becomes x to the positive 3, negative 1 times negative 3, y to the positive 15, z to the minus 3. And that's a fine answer, although a lot of times they prefer you to get rid of any negative exponents. So let's flip that z down to the bottom and make it a positive 3. So that's the first one. Another way to think of this here would be to say move all the negatives. If I had done it that way to begin with, it would have been x, y to the... No, that's not. Well, if you tried to flip all the negatives, you could make it x, and x squared y third on the bottom, and then that y to minus 2 could move to the bottom, the z to minus 3 could move to the bottom, z to the 4 could move to the top, and then subtract. I don't know if that's helpful, because then I think I like the other way better, but if you started that way, you would eventually get to the same place. Number 2, square root of 125 plus square root of 45. So each of these have perfect squares inside of them. 125 is equal to 5 times 25, and 45 is equal to 5 times 9. So we rewrite this as root 25 root 5 plus root 9 root 5 equals 5 root 5 plus 3 root 5. And again, we can do this because this is multiplication. Multiplication is only one step away from exponents, so we can split it up. Then you say, okay, these are like terms. We've got 5 times root 5 and 3 times root 5. So you can factor out the root 5, and it becomes 8 root 5. You don't have to write this step. That's just why collecting like terms works. But yeah, so there's your answer. For number 3, 27 to the negative 4 over 3. Okay, well, first off, the negative means flip to the bottom. So we would rewrite this as 1 over 27, and then 4/3 would mean the cube root and then to the 4th power. Now, you could do the 4th power first and then the cube root, but 27 to the 4th power would be really big, so I'd rather do the cube root first. And if you remember your cubes, which, again, I would say memorize at least the first 6 cubes, 1, 8, 27, 64, 5 to the 3rd is 125, we just saw that, and 6 to the 3rd is 216. Cube root of 27 is 3. And then we have to the 4th power, so that becomes 1 over 81. That is the simplest form of the answer. There are other forms you could write it in. If you left it as, if you got this far, I would have given you half credit, 1 point out of 2, but I really wanted you to go all the way to 1 over 81. Number 4 is a multiplication problem. So 1 plus 2x, x squared minus 3x plus 1. Maybe some people misunderstood this one, or maybe they tried to factor, but I want you to multiply this out. So since it's 2 by 3, I would use the grid method. You are, of course, free to use whatever method you like. Just make sure it's a method that works, and it's not something that works only some of the time. So we get x squared minus 3x and 1. X squared, 2x to the third, negative 3x, negative 6x squared, 1, and 2x. Then we go ahead and combine like terms. So we have 2x to the third. And when the squares of x squared minus 6x squared would be minus 5x squared. Minus 3x plus 2x would be minus x, and then a plus 1. So that would be your answer. And then some people start trying to factor this, which is weird because that would just go back to where we started. And I think some people thought you were trying to solve this, but note this is not an equation that we started with. This is just an algebraic expression. Really, we said this expression is equal to that expression. So this was a matter of simplifying, not solving. Let's turn to the back. Okay. X squared plus 2x minus 15 over x squared minus 25 times x minus 5 over x plus 2. So when we've got rational expressions like this, we'd like to factor everything in hopes that maybe some of the factors will divide out. So the numerator, we say, okay, we need two numbers that multiply out to negative 15 and add up to 2. 15 is a little hard to read. Let me fix that. So they multiply to negative 15. Go. So, what are two numbers that multiply negative 15? Well, we've got a few options. We've got 3 and negative 5. We've got negative 3 and positive 5. We've got 1 and negative 15 or negative 1 and positive 15. And if you do the sums here, 3 plus negative 5 is negative 2. This one is positive 2. That's our answer. These others would be negative 14 and positive 14, so they don't work. So this would be x minus 3, x plus 5 over x squared minus 25. Now, you can do the same thing and say, what are two numbers that multiply negative 25 and add to 0? That'll end up as being 5 and negative 5. Or if you recognize there's a difference of squares, you can immediately just jump to the answer there. X minus 5 over x plus 2. So now we're going to divide out any common factors. So let's see. What are common factors? Well, there's an x minus 5 on the bottom. There's an x minus 5 on top. So an x plus 5 on the bottom and x plus 5 on the top. So this equals x minus 3 over x plus 2 as long as x is not equal to plus minus 5. And with the way the grading worked and the curving, if you didn't get that, you could have still gotten a perfect score. But the point I want to emphasize is that this 5 and negative 5 are not in the domain of the original, but they are in the domain of this one. You could plug in 5 or negative 5 here and get an answer. And that would be cheating, because that would mean that it has a different value from the original there. That they'd have different domains. This one by itself would have 5 and negative 5 in domain, but the original does not have those. So we have to make a note that we're not allowed to use them because we weren't allowed to use them in the original. We want to say this new thing is exactly the same as what we started with, so for them to be the same, they have to have the same domain. Now, if you also said x is not equal to negative 2, that's fine. I wouldn't take off points for that. You just don't really need to because negative 2 doesn't work in either one of them. So it's really not, you don't have to make it as a separate statement. That said, you could state it right at the beginning. if you want to avoid this trick, avoid this trap of not sure which ones to take out, just say right at the beginning, domain would be the set of all the x in R, where x is not equal to 5, -5, or -2. And then in the simplifying process, it can't change the domain because we want the final answer to be exactly the same as the original. So you could just say, well, the domain is the same at the end as it was at the beginning. And that would be fine, even if you put an extra statement at the end. I wouldn't take off for that, as long as you don't leave anything out. So yeah, that might be your best bet with one of these rationals, is at the very beginning, write down what the domain is, and then use the same domain in your final answer. Okay, so number 6, x plus y over x divided by y plus x over y. So what I would do here is I would say, okay, what is the common denominator? Well, denominator here is there's an invisible 1 on those, and the denominators for these two are x and y. X, y. So the least common denominator would have to be x times y. We don't know if there's any smaller number that these could both factor into. Probably not, so we'll go with xy. So we multiply xy on top and also xy on bottom. And then we distribute. So that would give me x squared y plus, I'll write this out, xy squared over x divided by xy squared plus x squared y over y. And then I can get rid of some of those like that, and it would be x squared y plus y squared over xy squared plus x squared. And I guess for these domain issues we've been talking about, I should also say x cannot be 0 and y cannot be 0, because we have x's and y's in denominators all over the place, so neither one of them can be allowed to be 0. Okay, and the last one is factor an expression. 9x squared minus 36x minus 45. So I say, well, first off, I always try greatest common factor first. So if you're immediately jumping to like what multiplies to 45 and adds to 36, that you should not do that right away, because these, in fact, all have a common factor of 9. So we'll factor 9 out of all these. So I take out a 9 and say, okay, 9x squared divided up by 9, I get x squared. Minus 36x divided by 9, I get 4x, or negative 4x. And minus 45 divided by 9, I get minus 5. So now, this is, we've taken out the GCF, and the number in front of the x squared is 1. That add and multiply trick only works if the number in front of the x squared is 1. If it's something else, then there are other techniques, but we haven't gone over them. If it's something else, I would just use quadratic formula. So, we want things that multiply to negative 5 and add to negative 4. So what multiplies to negative 5? Well, there are only two options. 5, negative 1, negative 5, positive 1. I mean, there are other options, but there are only two integer possibilities. Add these together, we get 4. Add these together, we get negative 4. It's this one. So this would factor into 9, x minus 5, x plus 1. All right. So that's it. On the test, every problem was worth 2 points except for number 5, which was worth 3 points because of that domain trick you had to include. And then I added 2 points to your final score. You add up the number of points you got, divide by 15, that gives you a score out of 10, and then I added 2 extra points at the end of that. Okay. Please let me know if you have any questions. Bye-bye.